Okay, so looks like we are recording, and now you should be able to see my slides, right? Seems clear. So I'll speak today about data literacy, and literacy is something very basic, right? So it's the term assumes that this is something that everyone should have, right? And this term is quite important. And I will start with this quote from Bernard Marr. Doesn't matter who is this guy, but I really like the text. So let's read it together. So the more empowered employees are to read, write, analyze, and argue with data, the more they will be able to contribute first to their roles and second to the future of the organization. So you see there are kind of two important implications. First, it's your personal career will definitely benefit if you are good in data analysis. And second, our organization as a whole will definitely be much more efficient if every one of us really will be good in reading, writing, analyzing, and working with data. And okay, let me start with basic concepts. And this is actually the definition. So data literacy is the ability to read, understand, create, and communicate data as information. Period. Now we understand? We can close the session. Okay, let's go step by step. So which skills in, so this is maybe too short definition, so let's try to extend it. And the first skill is to know what data is appropriate to use for a particular purpose. Especially in our 21st century, we can collect a lot of data. For example, we can try, for example, make a picture every 5 minutes in our office. We can record maybe temperature, humidity, everything. And okay, sometimes this information could be useful, sometimes not. And this is not that easy to decide which is useful, which is not. And this is first skill. So once you start working with a project, to see kind of a priori, until the project begins, you need to decide it, because it's better to start collecting data from the beginning. So to decide which data could be appropriate to use, it's a really important skill. Surely there are some hints and ideas, but definitely it comes with experience. So the second skill is data visualization. And okay, this is clear when we speak about a lot. The third is understanding data analysis tools and methods. So currently there are numerous different, simple, advanced, very difficult, complicated tools. So you need to know at least several of them, and preferably be efficient in maybe a couple of them, like a guru. And the fourth point is data storytelling. So it's about communicating. This is probably the most important part was for me as a data analyst. So I told you that I am originally a mathematician. I like to work with data, to analyze, to get some insights. But at some point, you need to share this insight. And it turned out that it's not really simple because you spend on this data maybe a couple of days or a couple of weeks. You already understand everything about all the kind of nuances and etc. But then you have like 5 minutes with top boss to explain. And so that's really a challenge, right? To explain, to communicate this insight. And that's another skill you need to have, because usually boss don't have much time to listen to you. So you should be able to really formulate it with maybe some pictures, some diagrams, some graph, just to show exactly the insight, and don't tell the whole story. Okay, we started with D and we applied this method, etc., and then 2 hours later, you're kind of at the point where you can explain the insight. So you should be really able, and this is also very important skill. Okay, so let's start from data collection. Again, this usually comes with experience, but the most kind of important part here is to realize which variables are really important. So think in terms of characteristics or parameters of your system, which you really believe have a lot of information about your system. So basically, data collection is about measuring information on targeted variables, right? And then, okay, these variables then will enable to answer relevant questions and evaluate outcomes. So this is more or less simple part. Okay, the second part is not similar, simple that. Okay, for those who already know what CSV is and JSON, this is simple. But until you don't, you might be, okay, that could be difficult. But okay, anyway, so this is about data formats. If you try to look into literature and maybe Google search for data formats, you realize that actually there are very many data formats. Every application, every system usually has some specific format, some specific grammar to store information, but there are some really industry standards, and these two are the most major. So finally, if you really need to not just store information, but to communicate it, to send it from one application to another one, you will probably end up with either CSV or JSON. Okay, there is another one which I really like, which is called XML, but it's not that popular now because JSON becomes more and more kind of popular. But so let's stick here that just two, CSV and JSON. And CSV is not simple, it's very simple. So the idea is, okay, I wonder who needs me to explain you CSV? Or do I need to tell something, or it's kind of obvious to you? Okay. Everyone is silent. Okay, that's suspicious. Okay, so the idea of CSV is just the way to store a table in a file. So once you have a table, you have fixed number of columns and rows, and you can note that each line has exactly the same number of commas, like 1, 2, 3, 4, 5, 6. It means that this table originally had 7 columns. Because you have 7 and commas are in between. For example, let's check here. For example, 1, 2, 3, 4, 5, 6. So you see, so CSV, the only restriction for CSV, you have any kind of data inside, and then each line has exactly the same number of columns of commas, which could be easily transformed back into table format. And usually, the first line is reserved for names of your columns. And you see, this is kind of good example. So you start with comma. It means that the first column doesn't have title. So it's empty. And for example, if you have, for example, two columns empty, you'll have 2 commas, just comma, then next comma, just to keep this property that you always need the same number of commas. And okay, so this is total bill, like 16, 10, 12. Then the second column is tip. So here it's 1.1, 1.5, then gender, date, time, size, etc. So you see there are no formatting here. So this is just a plain text file. Okay, you may find it kind of not fancy, but this is the main advantage of this format. Since it's plain text file, every application on every operating system can easily kind of understand it. That's the main advantage of this file format. And JSON is kind of, the name comes from JavaScript object notation. And you see already in this name that it's about more complicated objects, like here. You have first name, last name, and age, and then you have address, which itself is kind of more complicated object because it has inside address, you already have some city, state, postal code, and you may have kind of nested different objects. So, okay. Finally, if you really would like to analyze that, analyze your data, you'll have to transform it back to CSV, because all the data analysis is usually discovered, is invented by mathematicians, and mathematicians don't understand what object is. So because CSV for them, it's okay, this is just vector, right? So you have just 7-dimensional vector, then simple. So you, okay, every mathematicians know what to do with high dimension space. And all the methods they design, they really based about this vector representation. That's why you always need to transform everything into a table with fixed number of columns and then apply everything, all kind of math. But until you have this kind of, you hardly can do any deep analysis with this structure, because you have, okay, this structure is very good for example, for if you need really to store data, store your data in database, for example, to make it like human readable and etc. But it's not really well tailored for analysis. So once you need to analyze it, you will find you need to, for example, transform this nested address into like address dot street address, address dot city, address dot state. So instead of like 4 parameters here, you will need to have 7 parameters. Or maybe you'll decide to skip some. For example, for your analysis, you don't care about city or state or postal code. You only need, for example, age and something else. So you just extract necessary information from this JSON, convert it to CSV, and then apply anything you would like from available libraries. So that was very simple introduction. I really recommend you to read maybe some tutorial on this topic that will be definitely useful, because there are some tricks and ideas about this format, but this too is kind of must for everyone. So until you understand JSON and CSV, don't even try to to do anything else. So another quite important topic in data literacy is data quality. So usually people kind of neglect this part because, again, for example, mathematicians don't care about data quality at all. In mathematics, you don't have this notion at all. You have like some numbers, you have some values, okay, and you can say that 7 is of better quality than 5. This is meaningless. So, but in real life, it's different. So once you try to collect the data, you will realize that there are 5 attributes which are really something which are specific in real life, but you don't have it in theory. So the first is accuracy, whether or not given values are correct and consistent. So, okay, no one is perfect. So if your data is collected by some person, then you might have some, okay, some, but even computer is not perfect. You probably it's difficult to accept, but that's true. So system might have bugs, or for example, sometimes it doesn't work just because your electricity is off. So you collect data, and then for another 10 minutes you don't collect data, then you collect again. So your accuracy is really an issue. So before you start data analysis, you should think about accuracy of the data, whether it's correct and consistent. Second is completeness, very close to accuracy. So sometimes you have gaps or missing information. Again, it depends on the topic, on your application domain. So sometimes you might have it like half of your data is incomplete. For example, if you do something like statistical survey, like every second person would probably skip some question. Because, okay, I don't like this question, or maybe I would prefer to skip this. So in some domains, this is kind of maybe 80% of your job to work with missing information. In our applications, in our domain, usually we work with computers and systems. Surely this is more rare, but still it might happen that your data is incomplete. Sometimes server didn't respond. Sometimes you, for example, okay, whatever can happen. So completeness is another very important characteristic. The third one is reliability. Okay, if you speak about human collected data, then reliability is more about reliability of the person who collected data. But in technical terms, reliability is about reliability of your method. You see, right? So, because you may think that your method really collects this kind of data, but actually this data is, for example, there is some hidden delay in your data measurement. So actually this data is that the real timestamp is slightly different, for example, right? And etc. So you should think about how really your method relates to the real value you would like to analyze. Then the fourth parameter is about relevance. So consistency between the content of data and the area of interest. That's what we started with, right? So some data could be, okay, could look useful, but it's really not useful. But some other data, it's always okay. Only experience can help. And the last thing is timeless. Timeline is quite clear. So usually it may take some time, and it might happen that your data is too late. For example, you need some real-time monitoring, and you have some complex processing module in between. For example, some fancy image recognition which sends data to server, to some cloud. It takes like 10 minutes, and then it returns in 10 minutes. Okay, some intruder was here 10 minutes ago. Then okay, it's too late. Everything is stolen already. So you see, again, it depends on your application, but timeless is also an important issue. Okay, let's go ahead. Data visualization is a huge topic. Just to mention here that it's really about communicating. So you not create your visualization just to, okay, surely just to feel happy and feel like, okay, I'm a really cool designer, but the primary goal is to communicate. So your visualization is really a message which everyone will read, right? So, and if it's not readable, then it's not good visualization, even if it's fancy from the point of view of design, colors, forms, etc. So if no one understands, then it's useless. And if it's really simple, but everyone likes and gets the insight, then it's good. So here are some hints. You should just try to fit it in small space and encourage people maybe compare some different pieces. And always it's recommended to visualize different level of details. Maybe something from kind of zoom in, zoom out, some more details, some more overview. And right, to see your purpose. You are describing, you're exploring, you're decorating, why you really need this visualization. Okay, and let's say a couple of words about exploratory data analysis. This is very important term, kind of standard term in our field. So usually you have kind of two different phases of working with data. So once you collected your data, assume you already decided which variables to observe, which format to use, definitely CSV. Okay, maybe JSON. So you collected your data, and so before you start really some maybe deep analysis, you always need to perform this EDA. And usually it's quite simple, so it doesn't take much time. Maybe, okay, if you're professional, it may take maybe 20 minutes. If you are not that professional, it may take maybe a couple of hours, but this is very important part. So, and this is just the list of questions. So you should tell what is the size of your data, what is the format, the source, then the data quality, right? If you have missing, and then what we call 5 number summary, which is the minimum number, maximum, average for every parameter, right? Then to check if it has some outliers and create some basic visualization. And this is quite simple. It already provides the user with some general overview. Are we working with like a small table from Microsoft Excel, like, okay, 100 lines, or you have like a drive with like 10 gigabytes of like data. So it's really important because for you it's kind of obvious, but for the person you start to talk to, it's not obvious. How big is your table? And for example, what kind of data is inside? Do you have like, for example, you have some collection about some data about monitoring the system? Does it consist of just real numbers, for example, some characteristics, or it has some like text, for example, error messages, right? it completely different. It requires completely different type of analysis, but someone has to tell it. So this data is of this size. It consists of this number, that kind of variables, this kind of variable. So each variable, for example, this is usually like in terms of seconds, like these parameters, and this, for example, in terms of like number of users. And like now, if you say number of users, again, if it's like between 10 and 100, or for example, if you just, for example, it's like complete complex configuration system, then your users are, for example, admins, right? Then you don't have many admins. So number of users is usually like 3, 5. Or is it kind of a very popular website where number of users like 1 million per second, right? So for each parameter, you provide this minimum maximum, and this already gives you like impression of what is the data, right? So, and right here, just 2 links to different papers with exactly the same title. The title is "What is Exploratory Data Analysis?" So you'll have access to this presentation, so I really recommend you to read. And I found 4 different Google Sheets tutorials, and I like each of them. So you can choose one. You can go through all 4 because they are not really big. So it may maybe take maybe a couple of hours to go through one tutorial, and you may like this style, the other style. So all are free, and so I really tried each of them. So this is kind of must. And okay, now the most interesting part of my lecture. Let's speak about data storytelling, but maybe let's make a short pause. Guys, are you here online? I wonder if you have maybe some question, comment. At least indicate that you can hear me and you see slides, please. So someone please type anything in the chat. Yes, Senor, thank you, Olga. Okay, so and now the most interesting part. I really like this example. Hope you like it too. So this is not so. Storytelling is about some clearer steps. So before you create a story, you need first to realize the context, right? What I'm trying to say. Why you need to analyze this data? What is the project? Why you collected it? What kind of expect for the data? Then you need to choose some effective visual because they are quite different forms and formats. And then you need to decide where will be the focus of your visualization, and then tell the story. Okay, and here's an example. Let's see these 6 pictures. Do you understand this story? I see some people probably understand. So who don't understand? Just raise a hand. So, but this is really, really important. So it's funny, but so notice there is no text at all. And I did not make any comment still, right? So I didn't tell you a word about this story and nothing is written, but you already understand something, right? Okay, maybe we understand it different, but I hope like everyone understand the same way. But I believe this is a perfect example for storytelling, and we should learn from it how to make a story. So let's see. So it starts with overview, right? So you create like a defined context. Okay, there is a tree, there is a boy, there is a girl, there is a hill. They are kind of different parameters of our systems. Like, so we have kind of this kind of objects, this kind of subsystem, another subsystem. So you describe like overview in one picture. Very short, with no details, but just to give the listener idea of what are the main parts of your analysis, right? Then you zoom in and say something in more details about one specific part. Choose some focus, right? And say, okay, let's show you, for example, this particular parameter. this particular parameter, it has this kind of distribution. Notice there's some outlier here, and this is minimal value maximum. And it's really interesting to see that, for example, it's kind of time series, all right? So it has some peaks in the midday and then some. So you just choose one focus, and you tell some small story about this object, right? Then you zoom into the other part, right? Okay. And also you see that there is another parameter. It's completely different. It's, for example, it's not numerical, it's categorical, right? So it has only 3 values, but usually they are kind of this kind of logic. You have kind of this kind of statistics, for example, here. And again, you speak this story about the other part. And then you show some correlations, right? You see, this parameter is not really independent from the other one. So there is some correlation, some. For example, if this parameter is, for example, this size, then this will behave that way. So you show some relationship between different parameters. And if I had maybe more space here, I would definitely spend some time on the tree, because I believe the tree is really important part here. And there is definitely some relation between the boy and the tree, and maybe between the girl and the tree, and maybe also the hill. So the hill has its own story, because this is the oldest part, right? So I believe hill is here maybe for centuries, and the tree is here maybe for decades. And you see there are kind of different levels of historical magnitude, right? So definitely you have. So it's really interesting to see the story for every single parameter. But once you start to feel this parameter, it becomes even more interesting to see relation between this parameter and the other one. So, and finally, you just conclude with some very specific insight, right? You say, okay, so the goal of this analysis was to show you that in this data you have, for example, this kind of observation, this is kind of my hypothesis, and this is what I suggest, some recommendations maybe, or maybe suggestions for future analysis, maybe for additional collection of new kind of data, etc. But conclusion is also a very important part, because again, some people usually, from a mathematician, for me it was the most difficult part, because as a mathematician I really enjoy working with data. Doesn't matter whether it's useful or not. But in a real project, you need to understand the reason for this project and what kind of information is really important for the team and which kind is not. And quite often, in my experience as a data analyst, it was so that the simplest observation was the most useful. So you should know, it's not really necessary to apply all these fancy tools, because sometimes just the short graph you show, like you see, for example, I worked on social network analysis, and I had some customer, and he suggested me like huge database of all his subscribers. And I started my presentation with the fact, you see, you have just 1% of followers who are very popular, like 50 people who have, each of them has like 10,000 followers. And he said, this is enough, because I can just invite those 50 to a party. And next day, 50,000 people will know how my party is good. You see? So all this fancy analysis wasn't, so just the simple statistics turned out to be very, very useful for him. He realized that, because usually if you have like 10,000 followers, you cannot do anything offline with them. It's too many people. But if you realize that there is a small influential group of just 50, you can just work with them just in personal way. So you see, sometimes just the simple analysis is really what the team needs. So, and this is about conclusion. So maybe the expectation just simple, okay, and you don't need any machine learning or auto detection. So, and okay, let's get back to this more serious scheme. So you see, actually, the the workflow is actually the same, right? This is recommended by some professional. So start from context, then choose some parts and relationship, and then just conclude with some story with clear conclusion. Okay, that's actually all about theory for today, and I suggest some home assignment for those of you who are really like this topic. So my suggestion is the following. So the assignment is obligatory for everyone, but the deadline is not set. So if you'll find time to do it in 1 year, it's okay. Just write me in 1 year. Rosti, do you remember last June you gave me this exam? Finally, I found some time, and I will be happy to discuss. So because each of you has some maybe projects to do and maybe too busy, but so I don't expect maybe to do it tomorrow. Also, I will be happy to start discussing tomorrow. So here's an assignment. So first, just look around to see what kind of data sets you can have. So surely there are a lot of different data sets available online, like open data, etc. But you already have access to internal projects. You may collect, maybe access some data which is already useful for clients, for your project. So just make this list and just look at it and maybe discuss with your friend, with your manager, what could be really interesting to analyze. Then just choose one and perform this exploratory data analysis. And okay, actually you can do it anyway, but there are two requirements. You must have a histogram and a scatter plot. This is just what I ask of you. And then just make up a story, like I showed you, with this data. Just choose maybe one parameter, another one parameter, try to play with it, show some maybe correlation, some dependencies, some relationship, and make just 3-5 slides, definitely not more than 10. And okay, probably not less than 2. So I can imagine someone would be really good in creating, there is this well-known poster style where you put everything on one page, so that could be okay, but probably at least 2, please. So then just send to me and be ready to maybe make this presentation to your friends, colleagues, to everyone, like 5 minutes to get some questions, discussion, because I believe everyone will benefit. And just to start here, just 2 examples. So kaggle.com is a perfect place to start your search. It has maybe like thousands of different data sets on completely different topics. And I found 2 which are directly related to our, so this is example from my lecture yesterday. The one is software defect prediction. It's about source code. So you just have different pieces of source code from some government project. And then, so you have 10,000 modules with 22 attributes. And so you have access to this data, you can analyze it and try to figure out some relationships. And for those who like really huge data, there's another example from Kaggle. So this data set has 27,000 files. And so in total, you have more than 3 million different integer parameters, 700,000 decimal parameters, 55,000 ID parameters, and some additional information. So you have a lot to do. But again, this is just, if you don't know what to do, you can find, for example, something not really real. Okay, this is a two example we are just learning, so you can take any example not really related directly to our data, just maybe to something. For example, economical situation in Sri Lanka is another interesting topic to discuss, or maybe some historical data or whatever. So thank you. That's it. And I plan next session in this series for Thursday. So questions, ideas, comments are welcome, and probably I will adapt my slides for Thursday according to what really need. So guys, online, questions, comments? Okay, I'm here in Columbus, so you can always ask me directly. No need to do it just now. So that's it. Let me stop recording.